In this lesson, you will learn how to represent three-dimensional figures with nets by analyzing their faces and bases. Because we are talking about three-dimensional figures, it's important that we understand what a dimension is. And I'm going to show you some examples of one-dimensional figures. Right here you see a ray, a line segment, and a line. And these have one dimension because they only have length. They don't have a width or a height. Two-dimensional figures have both length and width. A rectangle, for example, has a length and a width. So does a triangle, and actually all polygons are two-dimensional, or sometimes we might say 2D. You probably could guess then that a three-dimensional figure has three dimensions: a length, a width, and a height. Okay, we're going to jump into the core lesson, and we're first going to define what a net is. And a net is a two-dimensional pattern of a three-dimensional figure that can be folded to form that figure. So right here you see three different nets, and we're going to be exploring these over the course of the lesson. How might we create a net for a prism or a 3D figure like this one? The interesting thing about nets is sometimes there is more than one option of a net that matches up with a 3D figure. So all three of these nets could be folded up to form the prism that you see on the right. If you look closely at the nets, you see that each of them has 6 faces, and the prism also has 6 faces. Here's another illustration of a prism and its net. I want you to just watch closely so you can see sort of how the different faces correspond to each other, right? 6 faces on the net, 6 faces on the prism, and as you can see on this image, 4 of the faces are purple, 2 of them are green. This is to help you understand a little bit more how the net might fold up to form a 3D solid. Okay, right now we're going to match the 3D figure that's going to appear in a moment to its appropriate net below. And we're going to do that by closely analyzing the different faces that we see on the 3D figure. So if I look at this blue 3D solid, I see that it has 2 triangle bases and 3 rectangle faces. And what that means is the net is also going to have 2 triangle bases and 3 rectangle faces. So let's take a look at these options. Option A, as you can see, has 4 triangle faces and 1 rectangle base. So we know that that's not going to work out. Option B seems like a pretty good fit: 2 triangle bases and 3 rectangle faces. Let's just check out C to make sure that we want to stick with B. So option C we see has 2 triangle faces and 4 rectangle bases. Pardon me, rectangle faces. So what that means is there would be an extra rectangle in the net for option C. So we can conclude that letter B is the appropriate net for our triangular prism. Let's try another example. We have another 3D figure. This time it is a cylinder, and we're going to determine which of these nets is appropriate. What we're going to do is we're going to look at the dimensions and see if the dimensions of the rectangle face match up with those of the circle. So right here, the length of this rectangle seems like it might not quite wrap around the circumference of our circular base, which would be a problem because this net would not really fold up to form the 3D figure that we want. Let's check out option B. That height on that rectangle seems like it might wrap all the way around that circle, the circular base, but that length seems like it's not long enough to make its way around the circumference of the circle. In option C, we have a nice long length right there, which will certainly wrap around our circular base. And the other length is equally long. So it seems that option C is going to be the most appropriate, correct net to match up with the cylinder that we see in the right-hand corner. In this lesson, you have learned how to represent three-dimensional figures with nets by analyzing their faces and bases.